So, dear students, Jamil will present for us his project. Please, I want you to pay attention because you will ask him questions, okay? At the end of his presentation.
Can you see my screen?
Yes, Jamil.
Yeah, Professor, just I want to ask you, where should I submit the project? I
On
don't see
Moodle,
it.
on Moodle,
Yeah,
you have a
yeah,
you. If you go down in project, if you go down in submissions, you don't have submissions. Go down, please.
nothing.
So I will recheck because uh, I thought that I already did it. I did it. Maybe there is a certain error. Maybe it's hidden from students. I will make sure. But you should be
Okay.
able to upload it. Okay.
Yeah, yeah. I was checking since 3 days,
No
but
problem. I will check it again.
yeah, thank you.
Well,
Yeah, shall we start?
yeah.
Okay. Good evening, Professor. Good evening, everyone. Today I'm going to be presenting my project, which is about ocean warming and its effects on climate in the Arctic. I found this topic really interesting since it is a phenomenon which is recently happening and not all people are aware of it and its dangers. Okay, so first, what is ocean warming? Ocean warming is a phenomenon where ocean temperatures rise above the seasonal average temperature. It's obviously due to global warming. Oceans absorb the excess of heat from the atmosphere, where 93% of heat from the atmosphere is dissipated into oceans, causing a rise in ocean temperatures and hence ocean warming. Most heat absorbed by the oceans result from greenhouse gas emissions and the greenhouse effect, where the greenhouse gases reflect back and trap heat on Earth. Recent studies from the US National Oceanic and Atmospheric Administration has shown an average increase by 0.13 degrees Celsius of the global temperature since the last century. And even if you see this value, it's very small, it has caused a lot of changes in our ocean, negative changes, of course. Okay, so what are the recent trends in ocean warming? In case of business as usual scenario, it's expected that by 2100, the global ocean temperature will rise between 1 degree Celsius and 4 degrees Celsius, depending on the amount of greenhouse gases emissions. The annual ocean temperature anomalies in the graph to the right, as you can see here, are clearly showing rapid increase in ocean temperature anomalies. Most heat, almost two-thirds of absorbed heat by the oceans are dissipated through the top 700 meters of oceans. Hence, the surface ocean temperature is mostly affected. As shown in the figure to the right, down, the temperature anomalies of the ocean are not uniform and they vary according to locations from one ocean to the other. As you can see, that significant temperature anomalies are in the southern hemisphere. Usually, oceans act as a buffer to the atmosphere where it regulates the temperature and absorbs enormous amounts of carbon dioxide from the Earth's atmosphere. Analysis performed at the Grantham Institute showed that Earth's temperature would have risen by 36 degrees Celsius between 1956 and 2010 if the heat absorbed by the upper 2,000 meters of the ocean remained in the troposphere. So, can you believe how much oceans are essential? Ocean warming is triggering ocean thermal expansion. This is causing a rise in ocean levels along with ice melting at the poles. It's expected that ocean levels will rise between 0.5 meters and 1 meter by the year 2100. Okay, as you can see in this slide, the changing ocean temperature is also changing ocean currents. As can be shown in this image below, ocean currents are becoming weaker due to less circulation between the cold and the hot waters. Since cold water is becoming hotter, this is affecting weather patterns, migration, and marine species, migration of marine species, and the availability of nutrients and food. And it's forcing many species to migrate into other environments and for adaptation. As you can see here from the circulations, water here is becoming more fresh, and as you know, fresh water is less dense than seawater, so it is floating at the ocean surface rather than sinking to the bottom. This is causing weaker ocean currents. Okay, now as you know from thermodynamics that the heat capacity of water is much greater than that of air. That's the reason why ocean absorb a big part of heat from the atmosphere. Ocean heat content is used to quantify the amount of heat energy stored in ocean, and its value is indicated by the temperature. Ocean currents spread the heat absorbed at deeper depth and other oceans. So ocean heat content is calculated through the volume integration of water density, the specific heat capacity or constant Cp, as you can see here, and the capital phi, which is the conservative temperature. It's a function of temperature, absolute salinity, and pressure, of course. Here, H1 and H2 are the depths at which you want to calculate the ocean heat content. Another method for the determination of the ocean heat content is through simulation by statistical mapping method. This method maps the ocean by gridding, usually missing data. As you know, it's filled up by interpolation. The software simulates ocean temperature anomalies. Hence, normal ocean seasonal temperature is subtracted from the data we obtain in order to get the difference in temperature or the temperature anomalies. And this is mapped through this simulation. Okay. Here, three different agencies from different countries, which is USA, Japan, and Australia, have tracked the variation of ocean heat content with years from different stations in the oceans. All three have shown a significant increase in the ocean heat content. Technologies such as underwater robots, ships, airplanes, and many more were deployed by these organizations to measure the differences in the ocean heat content of different oceans and regions. As can be shown from the graph, the oceans absorbed up to 150 here, up to 150 zettajoules of heat, which is enough to raise the temperature of our atmosphere by 36 degrees Celsius. Okay, now we're gonna see the warming of our ocean surface. Since 1970, heat absorbed by the ocean is much greater than that reflected back. So as you can see here from the graph to the right, this is the relative proportions of heat absorbed by the ocean. As you can see that the oceans absorb almost 93% of the heat. The remaining 3-4% is absorbed by the cryosphere. Cryosphere, I mean that the areas on Earth which are covered by ice. 2-3% is taken by the continents, and the remaining 1%. Can you imagine how small? 1% is left in the atmosphere. Usually, more than 60% of the heat is taken by the upper 700 meters of ocean. Of the ocean, the remaining is dissipated through deeper depths, which is almost 30%. Okay, here the 2 years that have witnessed the highest temperature anomalies or change in the ocean temperature are 2014 and 2015. Here you can see that the global ocean, the global surface ocean temperature has risen by 0.3 degrees since 1970. It is estimated that the global ocean temperature will rise between 1 degree Celsius and 3 degrees Celsius in the case of business as usual. Here you can see that the ocean that's most affected by ocean warming is the Pacific Ocean, where it's mostly shown at the equator. It has the highest temperature anomalies. Also, the Arctic Ocean is also a victim of ocean warming. Okay, here now for sure the temperature of the deep ocean is being affected as well due to the heat flow from the ocean surface to the bottom. This is certainly affecting ocean current, heat transport, marine ecosystems, biodiversity, atmosphere, and the cryosphere. As I mentioned, cryosphere are the areas on the Earth that are covered by ice. However, the main cause of the deep ocean warming is not heat flow from the surface, rather than seabed volcanic eruptions. The temperature of the bottom ocean is increasing. Hence, the heat transfer between the bottom and the surface is reduced. This is trapping heat in the ocean. Temperature heat intake monitoring at the deep ocean below 2000 meters is somehow limited due to geographical data and poor seabed coverage. However, some stations showed that the deep ocean temperature is increasing faster than ever. For instance, stations in the Atlantic Ocean measured an average increase between 0.02 degrees Celsius and 0.04 degrees Celsius between 2009 and 2019 at depths ranging between 1360 meters and 4757 meters. Okay, in this graph, you can see how the percentage of global ocean heat content is changing at different depths between 0, 700, 700,000 and below 2,000 meters between the years 1860 and 2018. The data shown in this figure are from different Argo measurements and simulations, and as can be observed that the data from all of these stations are close to each other and give almost the same results, which means that all stations or all studies has proven that oceans are actually warming. Note that also volcanic eruptions are also simulated. It can be shown that the percentage of global ocean heat is increased lately due to increase in the seabed volcanic eruptions. You can see here the intensity of seabed volcanic eruptions that has been recorded recently. It caused rapid increase in the deep ocean temperature. Okay, how ocean temperature is measured? Now, ocean temperature can be monitored by shorelines, voice ships, Argos, and moderate resolution images, spectroradiometer, which is also noted as MODIS. This depends mainly on satellite observation. The MODIS system measures the frequency of microwave and infrared radiations emitted by the oceans. You know that ocean heat is emitted in the form of infrared. So the MODIS interprets the temperature according to the amplitude of the wave, knowing that the amplitude of the wave varies with temperature. So by capturing this wave, this instrument records the amplitude and interprets it into temperature. This method is mainly used to measure the ocean surface temperature through the satellite observation. For deeper ocean temperature measurements, drifters, moorings, and Argos are used. The instrument is placed at a particular place or particular location where it sinks to the desired depth, and then it's drifted with ocean currents. To track the device or the device's location, a GPS system is connected to the device. Here at the corner on the top, you can see the drifter. This is the drifter, and this is its dimensions. Usually they control the angle here in order to float or sink. It's connected to floating lines as can be shown. The image at the bottom here, we can see the mooring. While the right image, here to the right, we can see the Argo system, which is the most commonly used in deep ocean temperature measurements. Okay. Now, in this slide, you can see the schematic representation of the Argo system, where conductivity, temperature, and depth units are connected to the device. In addition, the device has a pump, as you can see, enclosed unit. What happens is that the CTD pump, which corresponds to conductivity, temperature, and depth, sucks water through the intake opening at the top. You see here the intake opening. The pump sucks water from here. Water then passes through the temperature sensor where temperature is measured. After that, it passes through the conductivity cell where, of course, the conductivity is measured. At the end, water exits from the exhaust opening that is aligned along with the intake opening. Here you can see water passes in this way until it exists here in the exhaust port. The pressure sensor is found on the float end cap. The unit measures the pressure of water and it interprets it with depth. Here you can see that the pressure port is not located inside the CTD or Argo system. It is outside, where here the pressure is measured, and then that rho hg h is calculated. Here you can know the depth at which the Argo system is located. Now, the right figure represents the Argo float mission, which is known as Park and Profile. This mission lasts for approximately 10 days, where here the Argo is placed at specific location where it sinks at a speed of 10 centimeters per second for 3 hours, reaching the depth of 1 kilometer. Ocean currents drift the Argo system for almost 9 days. Until then, it descends also deeper till the depth of 2 kilometers at speed of 10 centimeters per second. This journey also takes 3 hours. After that, it starts floating to the surface. It takes almost 6 hours at the same speed. So here, what the Argo is in the ocean, it's recording the data until it floats to the surface. The data is transmitted through the satellite, and it's interpreted where, as you know, the data is transferred to the simulation where it grids the ocean and shows a visual representation of the ocean heat. Then this journey is repeated again until battery death. Okay, so why it's essential to start fighting ocean warming? First reason, ocean warming is causing rise in ocean level. This is causing making low altitude areas and coastal prone to flooding. Oceans are undergoing thermal expansion, not to mention the amount of ice melting annually at the poles. As you can see here in the figure, that 45% of rise in sea levels is contributed by the melting of glaciers, 38% is by thermal expansion, 13% is melting of the Antarctic sheet, and the remaining 4% is ice loss from Greenland. These factors contribute directly to rise of ocean level. It's estimated that in case of business as usual scenario, it's estimated that a rise of 5 inches to 10 feet is possible in the next in this century. Okay. Here, another reason why we should fight ocean warming is the impact on ecosystem and marine species. Ocean warming will certainly affect many marine fishes, mammals, and seabirds. All of these species will migrate to find an appropriate environment for breeding, food, and good environment to live. Some species, such as killer whales and sperm whales, which live in cold environments in the Antarctic, are prone to extinction because these species are adapted to cold environments. So ocean warming will make them prone to extinction. Another phenomenon is coral bleaching, where corals, coral reef are losing their color, as can be seen in this image, due to starvation and the shortage in microscopic algae that die, leaving the coral tissue. This phenomenon is represented in the figure to the right, where it shows an image taken from the American Samoa. The top image is captured in December 2014. Here you can see that the corals are full in life. The one in the middle is taken in February 2015, while the one at the bottom is taken in August 2015. It can be clearly shown how corals are bleached during this period. In addition, as I mentioned in the previous slides, that 2014 and 2015 are the most years that encountered ocean warming. So, here we have also the effects of ocean warming is changing the ocean currents, as I mentioned. Temperature and salinity are the two most factors that control ocean currents. So while changing the temperature, ocean currents will be definitely change. Researchers shown that ocean currents has decreased by 15% in the Atlantic Ocean since 1950. Usually, cold water near the poles sink to the bottom and warm water floats to the top. This cold water near the Arctic is becoming warmer, and this is disputing water circulation. also slower ocean currents are causing more hurricanes and extreme temperatures. For example, summers in Europe are expected to be much hotter in the upcoming years. Weaker ocean currents means less nutrients drifting from the seabed, which is make many marine species prone to starvation. Many humans also rely on oceans for their income and for their food. So ocean warming will cause fish distribution. Hence, the fishing sector will become less, and this make many fishes also prone to diseases. Hence, humans will be vulnerable to disease transmission and infection. This will put food security and public health at risk, and hundreds of millions of dollars of economical losses is expected in case of business as usual scenario. Another thing, corals and mangroves keep seawater from rising, is being destroyed by ocean warming. So nothing will be left to protect our coastal areas. Okay, here another effect of ocean warming is ocean deoxygenation. As you can see here, that ocean warming can reduce the amount of oxygen dissolved in the ocean. Usually cold waters can absorb or dissolve more oxygen than warmer waters. As you can see here, that the waters at the equator hold less oxygen than the water at the Arctic. So this is leading to deoxygenation of the oceans. Studies from 2019 showed that the level of oxygen in the world's ocean has decreased by approximately 2% between 1960 and 2010. Another thing, this is, I guess, the most severe effect that ocean warming might have, which is ocean acidification. Scientists gave this term as global warming hidden evil twin. Oceans usually absorb 25% of carbon dioxide from the atmosphere, and as you know, that carbon dioxide reacts with water, forming carbonic acid, for sure with the assistance of carbonate. So species that use calcium carbonate to build their shells for shelter and food will be affected by ocean acidification. For sure, the more the concentration of carbon dioxide in the atmosphere will increase the effect of ocean acidification, and hence will lead many species to extinction. Okay, we can sit aside and watch our oceans being destroyed. Actions must be taken as soon as possible. Actions taken can be grouped into 4 categories, which include carbon dioxide mitigation. Here you can see that actions taken can limit CO2 emissions, enhance limit greenhouse effect. We can also protect our marine and coastal ecosystems by planning and performing environmental risk assessments. Adaptation, where we take species to an environment where they can adapt, and also we can adapt to reduce our food source from the oceans, and also repairing such as repairing natural carbon sinks and repairing natural marine ecosystems. Okay. The only way to solve this issue is to think of oceans as a solution for global warming and climate change. This can be done through the following steps. First thing, through ocean-based renewable energy. Ocean-based renewable energy can turn the ocean from a victim to a solution to global warming. This is done through generation of energy from offshore and coastal winds, ocean waves and tides, ocean salinity, and heat content. Technologies here involve using floating or fixed photovoltaic cells. Ocean windmills, fixed or floating, can be used in addition to heating and cooling heat pumps. Ocean renewable energy fall into 2 categories. First, we have the ocean-based renewable energy, which is designated by ORE, and we have the ocean wind generation, which is designated by OSW. Studies have shown by 2050 the ocean-based renewable energy can produce between 100 and 1900 terawatts of energy per year, and it can reduce between 0.65 and 3.5 gigatons of carbon dioxide emissions annually. While the ocean wind generation can produce between 650 and 3,500 terawatts per year of energy, and it can reduce between 0.11 and 1.9 gigatons of these emissions. So why shouldn't, what is the barrier that we shouldn't start implementing in energy sources from ocean? We should start shifting our dependence from oil and gas, which are the main sources of greenhouse gas emissions, to ocean-based renewable energies. Here you can see we have the system of floating photovoltaic cells. We can benefit from ocean areas in order to deploy these cells. And we have also the fixed windmills that can be used to generate energy from ocean or coastal wind. Okay, another action that can be taken is reducing emissions from wild fisheries. Usually emissions from wild fisheries originate from fuel usage, upstream emissions, transport fuel production, and non-fuel emissions such as refrigeration and vessel construction. These emissions account for 4% of the world's food sector production emissions. A solution here says by using advanced engines with better efficiencies can help reduce such emissions. In addition, we must reduce the